Okay, so we have these 6 steps that we're going to follow to graph a sine, or to take a graph of a sine or cosine function and find the equation for that function. So the first graph we're going to do is this graph right here. Our first step is to decide if it's a sine or a cosine graph. Now, if we wanted to think of this as the starting point and this is the ending point, then from here to here, it's a cosine graph. And you could do it that way. But right now, let's do this as a sine graph, because if we start at 0, go up, down, and back to here, there's one period. So starting at this is a starting point and this is the ending point, then we would consider this a sine graph. So that's how we're going to do this one. So we're going to call it a sine graph. Now the next step is to find where the center line is. The center line is also sometimes called the midline. And that is where the center of the graph goes through. Now, since this graph has not been shifted up or down, it's centered on the x-axis, then that means that the midline or the center line is 0. Okay, so whatever the center line is, that's our value of k. So this is the general equation that we're using right here. Since we decided that we're doing a sine graph, our general equation for sine is y equals k plus a sine of bx plus c. This k in the front is how much your graph is shifted up or down. Since it's not shifted up or down, that's why our k value is a 0. Okay, now the next step, step 3, is to find the amplitude. Okay, the amplitude is the distance from the center line to the top of the graph. Another way you can do it is you can take the maximum value minus the minimum value and then divide by 2. Our maximum value is 3. The minimum value is a -3. 3 minus a -3 is 6 divided by 2 is 3. Or just looking at how far it is from the midline to the top, that's 3, so that's our amplitude. Okay, so number 3 was the amplitude. Finding the amplitude is 3, which means that A equals 3. Okay, so that was step 3. Step 4 is finding the period. Okay, the period is the ending point minus the starting point. So for this graph, if we look at one period of the graph, we go through one cycle of the graph, it goes from 0 to pi. So that's the period, from 0 to pi. Algebraically, the way you could figure that out is the ending point is pi, the starting point is 0, ending point minus starting point, pi minus 0 is pi. Okay, so our ending point minus the starting point is pi. Our period is equal to pi. So now we use the equation that period equals 2 pi over b. And then we know that if the equation for the period is 2 pi over b, and by looking at the graph, our period is pi, we set those two things equal to each other. So 2 pi over b equals pi. Then we'll put a 1 underneath pi, cross multiply. Then we get b times pi is b pi equals 2 times pi, which is 2 pi. Divide both sides by pi and you get b equals 2. So now we've got our b. So far we've got k, a, and b. So for this equation up here, we need k, a, b, and c. So all we need now is c. Okay, our phase shift, step 5. The phase shift is equal to the starting point. And this is how we find c. Our starting point for this equation is at 0. Okay. One thing you'll always know, if your starting point is at 0, c is always going to be 0. But let's go ahead and finish calculating it here in case it wasn't a 0. The phase shift is equal to -c over b. Our starting point is 0, which is the phase shift. So that means that negative c over b equals 0. Okay, we know b, we figured it out in the previous step. B is 2, so we put a 2 in for b. So now we have negative c over 2 equals 0. Cross multiply. So negative c times 1 is the negative c. 2 times 0 is 0. Negative c equals 0. So c has to equal 0. Now that we've got k, a, b, and c, we plug all of them into the general form for the equation of a sine graph. And we end up with y equals 0 plus 3 sine of 2x plus c. If we get rid of those zeros, then we end up with just y equals 3 sine of 2x.